we're going to talk about graphing radical functions. So a radical function contains a radical expression with the independent variable in the radicand. So that means it's underneath the radical sign. So example one, graph each function and identify the domain and the range of each function. So again, on this one here, I'm just going to go ahead and make a quick t-table for you. Now, since it is a square root there, remember you're not going to have anything in the negative because that would make it not be a function, and they told you it was a function. So here's your x, here's your y, and again, I look at this right here and I kind of say, oh, what would make good ones there? And I'll say I can do 0 and 3 and 9. So I'm just gonna, and my graph's not gonna be great. So I'm gonna go 3, 6, and 9 here so you can kind of see what it looks like. And then I'm gonna go 1, 2, and 3 this way, and you'll see why here in a second. So that's my y value. So I plug in my x values, and I'll get 0, and I'll get 1/3 of 1/3 of 3 is 1, and the square root of 1 is 1. And then I used 9, and that would give me 1/3 of 9 is 3, and the square root of 3 is approximately 1.73. So we went ahead and we got something right here. And then at 1, it was at 3. And at 9, it was at 1.73. So about there. And it almost looks like it's a half of a parabola is what it should look like. So again, just make a t-table, or you can even put it in your calculator and see. Okay. The second one is g of x is equal to -2 times the cubed root of x. So again, I don't know why I didn't put graphs on this one. I'll have to go and see. But again, I always tell you to, on this one here, it made sense to just use 0, 3, and 9. All right, when you're not sure, go ahead and still do -2, -1, 0, 1, and 2. And when I do that, I'll get 2.52. I'll get 2. I'll get 0. I'll get -2, and I'll get -2.52. Oh, I forgot to do the domain and the range. So the domain on here, again, it's 0, and it includes 0 to infinity. All right. Or again, that's the way the college would like it. Your book will probably just tell you it's greater than or equal to 0. And your range is also from 0, because again, think we're going up. It's going to go from 0 to infinity. It's not going to go as rapid as the x direction. But again, on that one there, since we're using the big ideas for our homework, you should say y is greater than or equal to 0. So on this one here, let's go ahead and draw. I told you I'll go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And at 0, it's 0. At -1, it's +2. At 1, it's -2. And at -2, it's at 2.52. So something like right here. And same here, 2.52. Again, my graphs aren't that great, but what you should see is something that looks almost like an s. Well, it is an inverse of our cubic function, and our cubic function kind of looked like that too. And on this one here, what's your domain? It's all real numbers. Okay, and for your range, again, it's also that all real numbers, or you can say all real numbers on both of them. Okay. All right. Now I keep telling you, excuse me, you can transform graphs of radical functions in the same way you've transformed others. So again, we've done this part before. We've done the horizontal translation. Again, it attaches to the x, and they're just kind of giving you some examples here of x plus 3, x minus 3. Remember, I keep saying inside x, so if you see inside, it's in the parentheses there. On the outside, I say outside y, these are on the outside of the parentheses. The reflection, again, I keep telling you, if it's inside, it's over the x-axis, and a lot of times that one looks the same. If it's over the x-axis, it's on the outside. And again, they're kind of giving you an example. Here's the one I keep telling you, horizontal stretch and shrink. We say if it's a big number, it's a stretch, but with the horizontal, we flip it. All right. Same here. It looks small, so we say a shrink, but again, we flip it for the factor. The vertical one, again, it's on the outside. Again, the horizontal is inside x. And then the outside one here, again, it's going to stay the same. So if it's a big number, it's a stretch. Little number, it's a shrink. All right, and we've been doing these ones quite a bit, ladies and gentlemen. I hope we're getting better at them. All right, so let's look at the two examples I have here. So f of x is equal to the square root of x, and g of x is equal to x plus 2 minus 3. All right, so if we look at what we had up above, all right, we know we have x minus h plus k. All right. So if we look at this, remember we have a plus there, so we would write that as x minus a negative 2. All right. And our plus k is a minus 3. In this one, it was just the square root, so we've done that one before. Okay. So our h is negative 2, and our k is equal to negative 3. So when it's negative, our g of x then is a translation. And again, remember, when it's the plus, it's going to go left. So it's going to be 2 left. And then when it's minus on the outside, it's down. So we're going to go 3 down. Okay. And then b, we have f of x is equal to the cubed root of x is equal to, and g of x is equal to the negative cube root of 2x. So we have the negative sign on the outside. That should tell us it's a stretch, it's a reflection in which one? In the x-axis, again. But again, we're going to still have, we have to say this one first. All right. So we kind of have to, a radical sign is like a parentheses. So it's on the inside there. What did I tell you? On the inside, it is a times x on the inside. So that would give us a horizontal stretch. Remember, I keep saying when you hear the word horizontal, what do you do to the number that you have? You're just going to flip it. So by a factor of 1/2. That's the horizontal. And then again, the negative, it's on the outside. So it's negative f of x, right? So that tells us we are doing a reflection. In the x-axis. All right, and last page here. Next one's a word problem. The function e of d is equal to 0.25 times the square root of d approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function s of d is equal to 4.4 times ed. Notice that's on the outside. Approximates the number of seconds it takes a dropped object to fall d feet on Saturn. So write a rule for s. So they're telling that our s of d is equal to 4.4 times e of d, and our e of d is 2.5 times the square root of d. All right. And if we take 4.4 and we multiply it by 0.25, or think about it, that's just 1/4. So we're going to take it and divide by 1/4 or multiply by 0.25. You'll get 1.1, and that would still be the square root of d. So notice we do not distribute that 4.4 inside the radical sign. We never put anything inside the radical sign unless we're told it's a horizontal stretch or shrink. And then they're asking us how long does it take a dropped object to fall 15 feet on Saturn? So we're going to say our d here is now 15. And that will be 1.1 times the square root of 15. And you plug that into your calculator, and you will get approximately 4.3 seconds. And then the last one again, some problems we've done before. Let a graph be a factor by a horizontal stretch. Horizontal, remember, what do I keep saying? Horizontal. What is it? I want you to think about it. All right. By a factor of 3. And then after that is followed by a translation 6 units to the right. So right or left, that's inside x. So write a rule for g. I keep telling you your book likes to use h first. So it says first write a function h that represents the horizontal stretch of f. So remember our h of x is going to be f of 1/3 of x. So it's saying wherever I see the x, I'm going to replace it with 1/3 x. So in this case, it's just going to be the cubed root of, again, it's a horizontal stretch of it. So we did do that, and we're just attaching it to the x. There's your h of x. And then it says write a function g that represents the translation of h. So that means the second thing we're doing. And again, that was 6 units to the right. So when we go to the right, again, it's going to be -6. All right. So notice how it's still attached to the x. So we're going to write this then as the cubed root of, well, we have that 1/3 still from above, and we have x minus 6. And with that one, we can just go ahead and distribute that 1/3 through the parentheses if you want to. And then we'll give us 1/3 x. And 1/3 times -6 is -2. And there's that one there. So the notes just looked longer than they really were, people. You can do this.